Okay, welcome to the sixth session. After this, 14 more to go. There are a few things before we begin. One is that the solution for trigonometry problems is posted in the same place where trigonometry assignment was, so you can check that. And for most of the practice assignments, you had the answers right away. For practice question set 1, we are going to review that today. So let's begin. Let me open the practice set here. Assignments and practice question set 1. So the first question was convert the following: 2 square meter to 1 feet per 2 square feet. Let me check if I could grab that screenshot. Okay. Copy and paste page. Oh yeah. Okay. So the first question was you are required to convert from 2 square meter to feet square. So the trick is different, simple. So I just replace meter with the feet, but you need to have a conversion factor for that. And that was in the example. It is 3.28. 1 meter is equal to 3.28 feet. So what you have to do, just take m out of the story and insert 3.28 feet, but you have to be very careful because of the square. The square is being applied on the m. So when you take m out of it and you replace that with something, the square has to apply on the whole thing. Okay, so this is one thing you cannot miss. So it is 3.28 feet and whole square. It means that it is 3.28 squared multiplied by feet squared, because for the multiplication, it is very easy to work with the power. For example, a multiplied by b and whole raised to power n is simply equal to a raised to power n multiplied by b raised to power n. So it is not difficult at all. In addition, it is different. So be careful with that. And I'm not going to put you through all this addition kind of things, but multiplication is very simple, so you should know that. So over here we have 3.28 squared, and then we have feet squared. So feet squared is what we need. So we'll take it out, and 2 multiplied by 3.28 multiplied by 3.28. The answer is 21.52 square feet. Second question was 40 miles per hour, and you are to convert that to feet per second. Now, how many feet in miles? So the conversion factor is over here, 5,280. So if you take mile out of here, then you have to replace that with 5,280 feet, because this is what we want in the answer. So our target is feet, so we use that. And hour is 3,600 seconds, so we put that because we require feet per second in the answer. And again, solve this numerical part separately and feet per second aside, and you have 58.67. 8 meter per second, and you were to convert that to feet per second. A very simple, meter is equal to, again, 3.28 feet. So just put that here. Second, you don't need to touch that. It is just because it is already there. Sorry about that. Okay, so now, yeah, just feet per second, and you have the answer, 10 kilometers per hour, and you want to convert that to meter per second. Again, kilometer is 1,000 meters, so replace this kilometer with kilo, the 1,000. So 1,000 is here, meter just as it is, meter. Hour is 3,600 seconds, just put it there, solve it, 2.70 meter per second. 12 feet per second, and you are to convert that to meter per second. There are 2 ways. One is that you need to have a conversion factor from feet to meter, But if you don't have that, then you already have the other conversion factor that is from meter to feet. So you know that there are 3.28 feet in a meter. So it means that there are 1 divided by 3.28 meters in a foot. So you can use that, just reciprocate. And that's I have used here. Rather than going through all that other conversion factor, I just used the one that was already given. And 3.66 meter per second is the answer. Second question is again another conversion, but this time we are dealing with prefixes in the same system. So 1 square meter, and you have to convert that to centimeter square. It is a solved example. And that's different. Okay. So now the question is, what do you want in the answer? In the answer, you want centimeter to appear. So what is centi? Centi is 10 raised power minus 2. If in exam, if you are required to solve this kind of question, I'll give you these values. Centi is equal to 10 minus 2. A kilo, no. A milli, you should know that. But centi, deci, this kind of, I'll tell you. Micro, again, you should know micro. You should know mega. But giga and this kind of, the prefixes that are not very commonly used, I'll provide that. But kilo, milli, mega, and the micro, nano, these are the ones you should know. So first point here is that you have meter, and you want to bring centi in this discussion. So centi is 10 to the power minus 2. So what you do, simply multiply and divide by 10 to the minus 2. The simplest way. So once you do that, this 10 to the minus 2 and this meter, that will become centimeter, and you are left with 1 divided by 10 to the minus 2, and that is 10 to the power and whole square. So that is 10 to the power 4. Very simple way. Similarly, over here, Kosika, you have a question? In part A, over here, yeah, because of square. I just want to make sure that we apply square on the whole thing. So the problem here is, let me show you that. One mistake that can very easily happen and this is what we have, and it is very easy to miss this square part. No, it actually does not. So that's why I use bracket. Yes, exactly. Okay. Keep going. What will be the next step? You already have a meter out of this text, so place meter somewhere in the second line. Where should the meter be? Well, it's not possible. So that's not, take the whole thing, start from here. 1 meter squared. Okay, now start from here. You may have other methods that I'm not really getting. Nice. So it is very easy to miss that square on the number side, and you end up with half a power on the number side, and you have centimeter squared over there. Yeah, 10 to the power 10 to the minus 2 replaces C, but it has to be in a square. You cannot drop the square because the square is applying on the whole meter. We can crudely write it another way. If it is meter square, then you are actually converting that to centi squared meter squared. Sorry. Okay, you need to be very careful with this part, and that's why I keep the whole thing within the bracket. My method to approach these questions is simple replacement. It is just like if you're taking something out of a drawer, you replace that with something else, and the whole thing remains in the drawer. It does not tear apart. So over here, if you do not put a bracket and you just take meter squared, as you are saying, then the room for error is the squared part on the number side, 10 to the minus 2 divided by 10 to the minus 2. So this is where you can miss the square, and that will be the mistake. Because it is centimeter squared, so centi part should also be squared. It is not only 10 to the minus 2. It has to be 10 to the minus 2 squared. So to minimize the room for error, room for mistake, you just keep the whole thing in the brackets. It was. This is exactly what I am saying, that the error that can happen. The correct answer will be 10 raised to the power. You can use 10 to the power 2, okay? I don't mind if it is minus 2 or 2, it's the same thing. But where you cannot ignore is this part. You miss this part. You see? Because the square, if I got where the confusion is, this square is not only for meter, it is for centi as well. So you need to bring 10 to the power minus 2 whole square. And it is very easy to forget that, just like you wrote that. It is the common mistake. So actually after 1 or 2 years of seeing this error again and again, I came up with this method that, okay, this is the method where the room for error is very small. So what you need to do, if it is square or cube, whatever it is, keep it there. And when you are replacing something, just keep that inside the bracket. And the bracket makes sure that whatever the operator you are applying on M gets applied on the whole substitution, so you don't miss anything. Is that clear now? Good. Over here, it was, okay, we already finished this, so I can remove that. Back to the problem. So radius of sun in megameter, kilometer, and centimeter. You can get the radius from Google very easily, and all you have to do is just to take 10 to the power 6 aside, and that will become mega, then 10 to the power 3 aside, that will become kilo, and then so on. So very simple. To micrometer to nanometer. Nanometer is 10 to the power -9. So if you want to introduce that, what do you need to do? First of all, simplify what you are given, 20 micrometer. Okay, there is no square, no cube involved, so I don't need to use brackets here. Okay, that done. So this is 20 microfarad, and because I want nano in the answer, so what I'm going to do, I'm going to multiply and divide by nano. And nano is 10 to the power -9. So 10 to the power -9 divided by 10 to the power -9. Now the red part is basically nanometer. So I am left with 20 multiplied by 10 to the power -6 divided by 10 to the power -9. And rest is just simple arithmetics. And you have 2 into 10 to the power 4 nanometer. Similarly, 200, it is 2,000 kilometer to megameter. Again, take 6 zeros aside, and you are left with 2 into 10 to the power, wait a second, kilometer, not meter, it is kilometer, yeah. So first of all, you have to convert the kilo to the number, and that is 1,000. Now you have the whole thing in numbers. And now you have to introduce mega. So 10 to the power 6, multiply and divide by that, and the red part is megameter, and you are left with this. Just solve it, 2,000 megameter. So if you just follow that basic method, it is not very easy to make any mistake. So just stick to that, please. And make sure you review this slide, and especially the boxes over here. So this is very helpful. Okay, now question 3 is, what are these points in XY? Where are these points in XY plane? So let's do that. Let me take a screenshot and put it there. New. And and the background, let's change that background to axis. Okay, now A2 minus 7. So just tell me, what quadrant will that be? I need 7 more answers. Quick, please. Emma, Kelly, Nikki, Paul, hurry up. Stacy, Stephen, we're all there. Okay. Okay, so let's see. A is 2 plus 2. So you have to go 2 steps along positive x-axis. And then minus 7, you have to go 7 steps along negative y-axis. So excellent, it is in the 4th quadrant. So 2, 5, 2, somewhere over here. So similarly, you can find B, 3, minus 8, and let's solve for D. D is minus 2, minus 3. So what quadrant will that be? Again, hurry up, please. Okay. X is negative. It cannot be 4th quadrant. Okay. So D is minus 2. You go 2 steps along x-axis over here, and then you go 3 steps along negative y-axis. So the point is over here. And now let's solve the last one, E10. What axis is that? Is that positive x, positive y, negative x, negative y? Which one? No, it's not coordinate at all. It is on an axis. So which one is that? Positive x, positive y, negative x, or negative y? Yes, it is positive x. Okay, just one step along, positive x axis or right over there. Good. So it is not a coordinate at all. It is the boundary. Okay, so you should know that. Fourth question is about the distance formula. So the distance between C and D, x1 minus x2 squared plus y2 minus y1, sorry, x2 minus x1 and y2 minus y1 squared and whole square root. Just simple method, and because we are trying to find out distance, direction does not matter. I don't care if you take C as 0.1 or D as 0.1, the distance will be the same in both cases. So yeah, very simple. So the answer is right there, and you can check yours. And then we have, without using grid paper or XY plane, tell in which quadrant following points lie. A, 1, minus 8. Which quadrant is that? A. Okay, good. It is fourth quadrant. What about B? Excellent. It is third quadrant. What about C? Okay, in C, we are going one step along negative x-axis and then 7 steps along positive y-axis. So that is second quadrant over there, okay? Minus 1 plus 7. Okay, what about the fourth one, D57? What quadrant is that? The simplest, 1. Okay, good. Next question is, Earth is this much kilometer away from Sun, and it is such a huge distance that the sunlight takes 8 seconds, about 9 seconds, 8 to 9 seconds to reach us. So it means that if you ever try to look at the sun, you are looking at something 8 seconds in the past. Isn't that a beautiful concept? No. To me it is. Express this distance in megameter and gigameter. Speed of light is 3 into 10⁸ meters per second. How long does the light take in seconds to reach from Sun to Earth? So this is the distance over here. Question 4. Question 4 is the distance formula. So I did not discuss that in detail, but right here. Okay? Okay. So first of all, remove kilo and make it a simple number. And now what you have to do is just introduce mega. Take 6 zeros aside, that will be your mega, and you are left with 149,600. And similarly for giga, because giga is 10⁻⁹. And now C is 3 to 10⁸ meters per second. So once you have this number like this, the calculation is very simple, and you get this answer over here. That was a good one. Amy flew around Earth along equator. Calculate distance and displacement for this table. Hint is the radius of Earth is 6.4 into 10⁶ meters, and circumference of the circle is 2 pi r, where r is the radius. So for this question, of course, I'm not expecting you to understand the relation between radius and circumference and all that, because I just gave you that information. The requirement was to use these prefixes and apply arithmetic operators on that and get the answer, and the difference between distance and displacement. That was the main thing. So distance 2 pi r, 2 pi and r is over here. You solve it and you get 4.02 into 10 to 7 meters. Displacement is 0 because she got back. She flew around Earth along equator, and it is of course assumed if she flew across equator, she came back to where she flew from. So the displacement is 0. That was a catchy one. Draw x and y coordinates, components of vector 5i minus 10j. So 5i minus 10j means that you have to go 5 small boxes along x-axis and then 10 small boxes along negative y-axis, because j is the unit vector for y-axis and it is negative, so it is negative y-axis. So this is our vector over here. Now, mathematically, find the direction. So, okay, you have the formula. Tangent is equal to minus y component divided by x component, and now you know where did this formula come from. So tangent of area is equal to minus 2. You put that in the calculator, and you get the answer minus 63.43. Most probably, if this question comes in the exam, minus 63.43 will not be one of the options. So you may be stuck there, and why am I not getting the answer? And I explained that part, that our convention in the physics 1 and physics 2 will be that we'll always keep the angle positive. In order to have a positive angle, you need to make sure that you are measuring it anti-clockwise starting from the reference axis. Reference axis in most of the cases is positive x-axis. Now this minus 63.43 means that the angle is measured clockwise, not counterclockwise. That's why it is negative. We are going in opposite direction, right? So minus 63.43 is this red arrow over here. So this is exactly what we found. But is this the angle that is required? No. The green one is what I need, because, as I said, it has to start from the x-axis and it has to go counterclockwise. So the green angle, how can you find that? We know that the full revolution is 360 degrees, right? So 360 minus 63.43, the answer is 296.57 degrees. And that is the right answer. That is the correct answer. Even if you wrote minus 62.43 in the submission, I'll consider correct. But for exam, the only thing is that minus angle may not be in any may not be a choice. So now you know how to deal with this kind of issue. So half of that was already resolved, and it is actually slide 43. Sorry for this. Slide 43 of unit 1 shows an example of addition of vector that was Heckel rule. Graphical method is used to find a plus b. Using the graphical method, draw b plus a. And is it the same as a plus b? Of course it has to be. So this was what I did in the that was in the slide. So that was a, and that was b. So using Heckel rule, this is what you get. And if you go the other way around, you go minus 3i minus 2j first, and you put minus 2i plus 5j next to that. Again, it is the same vector as this one is. Actually, these sides, all of these make us a rectangle, and that vector is the diagonal to that. If you put all this together, it will be something. If you combine these two, it will be something like that. So that's why the sum vector, the addition vector, comes out to be the same in both cases. And that was actually the fun part of it. A is 2i plus 5j and B is 3i minus j. So A plus B, just add the respective components, and you have 2 plus 3, 5i, 5 minus 1. It is j, so it is actually 1j. If there is nothing, then that is 0j. Okay. So 5 minus 1, 4j. So the answer is there. B plus A will be the same. Similarly, A minus B, A dot B. We know that in A dot B, the different, only the respective coordinates survive. Other two factors, you can ignore that. So 2i multiplied by, dot 3i. That will be 6, and I dot I is equal to 1. So 6 and 5 multiplied minus 1 is equal to minus 5. So 6 minus 5 is equal to 1. And because it is a scalar product, direction does not matter whether you go A dot B or B dot A, it is the same. That is not the case with A cross B. A cross B is in the opposite direction to B cross A. If you remember, we use head to tail rule, right hand rule. So in A cross B, you can ignore the respective coordinates and you have to go I cross J and J cross I terms. So 2I cross minus J, that is minus 2k, and then 5j cross 3i, that will be minus 15k, because it is 15 and minus k. So minus 2k minus 15k is equal to minus 17k. If you change the order, you will get 17k, and that is minus of this. In vector, negative or positive actually show you that the direction is different. So that was all about practice question set 1. If you still have any questions, please let me know so I can explain that. Okay, before we begin kinematics, another thing that I forgot. This coming Friday, something just came up, and I'll not be available in the evening. I can change the time to the earlier time, but I'm not sure how will that affect your schedule. For example, we can make it like 5 EST PM. So I'm reluctant to go that way. Instead, I am thinking about holding canceling the Friday session and holding a session Saturday morning. So let me know if the Saturday morning works for you. Take your time, send me an email by tomorrow, and we'll just finalize that. Okay, yeah, it's really up to you, because it is evening, so some of you are working, and you may not be able to reach back home by that time, 5 Eastern Standard Time. So I'm not really sure. And I'm not going to use this time here to ask this question. Check your calendar, check your own schedule, and by tomorrow, let me know whatever works for you. It is either 5 p.m. Eastern Standard Time on Friday, or on Saturday it will be around, you can say 11 EST. So let me just write it here and make it twice. Either where is the text size? So these are two options. So just let me know. Manage classes Saturday for block 2. Wow. Okay. Let me check that quick. Saturday. This Saturday. Yeah, that's crazy. you are hardworking people. 9 a.m. my time. So yeah, just check and let me know. Okay, whatever works for you. Yeah. Friday 6 p.m. will work. We try to tell you we got 9 a.m. till 4 p.m. Oh, okay. We have class until 3 p.m. Saturday. Okay. Okay, so okay, let's finalize this right away. Does Friday evening 5 p.m. work for you? Because it is very important for me that all of you are there. Paul, doesn't work for you, okay? Okay. Okay, then let's just cancel it, and we'll think about covering for that later. Okay, no class on Friday, nothing on Saturday. Just have fun. Okay. Yeah. End of discussion. Okay, so kinematics. So now you are equipped with the fundamentals, the basic knowledge of how to deal with these mathematical problems. Now let's dive into some serious stuff. Kinematics. What is kinematics? The origin of this term is the Greek letter, the word kinema. It means motion. And kinematics involves study of motion regardless of the force behind that. So once we get to the next unit, that is dynamics, then you'll be able to better appreciate the difference between these two. But for now, just understand that in kinematics, we study the motion of the object, but we do not really care about the force that is behind that motion. If we start studying that force as well, and we are asking questions like that, okay, if something is running at that speed, and how much do I need to increase the force to increase the speed to that level? That is where we are leaving kinematics and entering dynamics. Okay, so kinematics is another simpler, but there are three beautiful things in kinematics. So let's start. Important concepts in kinematics is position. We have already learned that, but we'll review that again. Similarly, distance, displacement, speed, velocity, and acceleration. These are the important concepts we are going to learn and we are going to use in this unit. So position. As you know, in Physics 1, we are mainly going to stick with two-dimensional or one-dimensional scenarios, not three-dimensional, so your life is easier. How do we represent position in physics? We usually have graphical method. We have XY plane. We draw the points. Okay, the person was here, got there, and then we just find distance or displacement, whatever we want to do. Let's look at this example here. So in this motion is strictly along a straight line. So this is one-dimensional case. The person started from A, went to B, and then went to C. Now please tell me, what is the total distance in this case? What is the distance from A to B and then B to C? Okay. 12 is equal to 16. Oh, maybe, I guess you, yeah, 12 plus 16 plus 28. Okay. No, you meant 12 plus 16 is equal to 28. Okay. Yeah. Okay, so yeah, from A to B, 12, and then of course the person went from B to C. So first the person got from B to A, 12 plus 12, 24, and then A to C, that is 16. So answer is 40 meters. Okay, the distance is 40 meters. What is displacement? Remember, displacement is, okay, we are already getting correct answers. Very good. Quick, quick. Only 2 answers so far. That's not good. Trust me, if you participate in the class, it will be about 50% less work for you later. So please, pay attention here and respond quickly. So it is 16, yes, because displacement is you can say the distance between the starting point and the end point. So starting point was A. Doesn't matter if the person went to B or X, Y, Z or Z, whatever, but started from A, went all the way to C. So the length of the line joining A and C is 16 meters. So displacement is 16. And because we have to give direction as well, so it is along positive x-axis. Okay? Very good. So this is another scenario here. So the person started from here at the point -5, -5, and took this route, this red line, and reached 74, the point 74. So if you want to find the distance, just add the length of these hatches, and you get 39 here. But displacement. Now the displacement is the length of the straight line joining the starting point and the finishing point, and that is this dotted line. But I want this in a vector form, right? So what do I need to do? For the x component, I need to drop a projection from here to this line here, and then this line, and these two vectors are basically x component and y component. But we'll talk about that again later. But the main thing is that this is the displacement, the dashed line, blue one, and this maroon or red line is distance. Now, another concept is average speed. In everyday life, we use the word average. We just sum the values and divide by the number, and we get the average. Don't do that with average speed, okay? That is very important. For example, A travels 4 kilometers at 40 kilometers per hour, and then another 4 kilometers at 50 kilometers per hour. What is the average speed? It will be wrong if you just take average of these two speeds and you end up, oh yes, it is 45 kilometers per hour. No, it is not right. What you have to do, you have to find total time for that, you have to find total distance, and then you get the speed. Okay? So total distance, we know it is 4 kilometers plus 4 kilometers, is 8 kilometers. But what is the total time? So now you have to find time in both cases. Okay? So speed is equal to distance divided by time. So time is equal to distance divided by speed. So distance is over here, speed over here. Again, for the second case, distance here, speed here, and you get 0.18 hour. And when you solve that, you get 44.4 kilometers per hour. That is entirely different from 45 kilometers per hour. So be very careful with that, okay? And there are exceptions when you can use that when acceleration is constant, but don't fall for that. Just use this one method so that you don't make any mistake. Always make sure that you are not averaging the velocity or speed. Find total time, find total distance, and then calculate speed. Okay, now, interesting part. Now we are going to deal with two graphs here. One will be position time and other will be velocity. 8:15. Let's take a 5 minutes break here, okay? And I'll see you again in 5 minutes. Okay, welcome back. So position time graph. rather familiar thing. So let's enjoy some discussion here. Slope in this plot. Slope is basically, mathematically, it is y component divided by x component at any section, you can say. And physically, the physical significance of slope in position time plot is that it is the velocity. So we'll go through all that by example. So what is really happening here? We have time along x-axis, so it is like you have a stopwatch. 1 and 2, 3, 4, 5, 6, 7, 8 seconds is the total time you have studied a motion. And during that 8 seconds, the person was at 2 seconds, the person was at point 3. Essentially, it is motion along x-axis, only one single axis. So let's say it is along x-axis. So the person was at point 3, and then at 3 seconds, the person was at point B, that is 5. At 4 seconds, the person was at point C. At 5 seconds, the person was at D. At 6, at E. And at 8 seconds, the person is at point F. So this tells you the whole route. Now tell me, because we just discussed what is really happening, what is really happening here. Is this motion all in one direction, or the person changes the direction? What do you think? Okay. Okay, exactly, good. At point D, we see that person is now changing direction. So let's plot x-axis over here, and let's mark it 9, 1, 2, 3, 4, 9. Okay, so what is really happening here? At 2 second time, the person is at point A over here. Okay, because A is 3 meters. At 3 seconds, the person is at 5. So 4 and 5. At 4 seconds, the person is at 8. Okay, 6, 7, 8. At 5 seconds, the person is at 9 over here. At 6 seconds, the person is at 8. So from 9 to 8. Now the person, initially, until point D, the person was walking in this direction. And now after 5 seconds, now the person is going in this direction. Even if the person is in the positive x region of this two-dimensional plane, his direction is along negative x-axis now. Okay, he's facing negative x, you can say, in that direction. Not moving along negative necessarily, but of course the direction is the same. Okay, now at 6 seconds, the person is at point 8 over here, and at 8 seconds, the person is at point 1 over here. Okay, so the person started from here, went all the way there, and came back here. Now let's discuss this in a little more detail. What is the distance between A and B? What is the distance between A and B? Only 2 answers so far. Hurry up, please. Yes, it is 2 meters because B is at 5 and A is 3, so 2 meters. Now, now you can see that the distance between B and C is 3 meters, A and B is 2 meters, C and D is 1 meter. And all these distances are being covered in 1 second. So from A to B, you can see that this is just 1 second along this time axis. B to C is again 1 second along time axis. C to D is again a 1 second long time axis. So you tell me please, which path is the fastest? AB, DC, or CD? Which path is the fastest? Yes, DC is the fastest, because here you can see that 3 meters in 1 second. Okay, CD is actually the slowest. It is 1 meter in 1 second. Now you can see how can you read this position time law and get all this information out of here. From A to B, this person did 2 meters in 1 second. From B to C, this person did 3 meters in 1 second. C to D, 1 meter in 1 second. So CD is actually the slowest one. How about 7 meter and 2 as E to F? I didn't ask that question. Okay, yes, you're right. That will be the fastest maybe. Yeah, 3.5. Yes, exactly. That is the fastest. Okay, now we are going to talk about velocity. So in velocity, you need to consider the direction as well. Okay, and that velocity, for the velocity, you divide displacement by time, not distance by time. One thing, and displacement is always final position minus initial position. Remember this. This is very, very important thing. If I say that out of today's session, one take home, displacement is always final position minus initial position. That is very common mistake to use initial minus final, final minus initial, just mixing that up. No, don't do that. It is always final minus initial, because you are trying to find out the change. The final may be a smaller number, okay, and but you shouldn't get confused by that. It is always final minus initial. So velocity between A and B. First of all, tell me with direction, plus or minus. What is the displacement from A to B? Good. It is plus 2. Very good. And what is the displacement from D to E? D to E cannot be 0. No, D to E. I just thought this out. Let me encircle that. This is what I'm asking. D to E. D for David, E for elephant. So what is the displacement from D to E? 4.5. You are missing one point there. It is final position minus initial position. Final position is 8. Initial position is 9. So displacement is 8 minus 9 equals minus 1 meter. Okay, good. Now what about the displacement from E to F? What is the displacement from E to F? Okay, so final position is 1. Initial position is 8. So displacement will be 1 minus 8, and that is minus 7 meters. Very good. So now we have learned how to find out displacement, so now we can find out velocities as well, right? So please tell me, what is the velocity from A to B? You just need to divide displacement by time. So velocity from A to B, dispatch. Excellent. It is 2 meters per second and positive. Good. Okay, now let's do something different. Tell me the velocity from E to F. Velocity from E to F. So what is minus 7 divided by 2? Oh. What is minus 7 divided by 2? Solve it yourself. Okay, yes. Good. Yes. So, again, first you have to find out displacement. Displacement is 1 minus 8 minus 7 and divide by 2 seconds because the time it took is on E is at 6 seconds, F is at 8 seconds, time is 2 seconds. So minus 7 divided by 2 is equal to minus 3.5 meter per second. Very good. Excellent. So it is telling you that the magnitude part is 3.5, but the motion is now negative axis, and we know that this is what was happening. So now the question is, what is the average speed and average velocity from the trip? Okay, so the hint is first let's find out average speed. Okay, so for that you have to find out, you have to add all the distances and then divide that by the total time. So please tell me, what is the average speed here? What is average speed? So first of all, the distance 2 plus 3 plus 1 plus 1 plus 7, that is 14. So that is one hint. And the distance is 14. And what is the time? And then just divide this distance by time and give me the answer. Okay, what is total distance? What is total distance from A to F? I need 8 answers, quick please. Very simple graph, look at that and just tell me, what is the total distance? 3 answers so far. Total distance is from A to B, it is 2. 2 plus 3, 5 plus 1, 6 plus 1, 7 plus 7, 14. Okay? Total distance is from A to F, not from the origin. So 14 is the total distance. Total time, the motion, the person was at A at second, and the finishing point is 8, so the total time is 6. So 14 divided by 6, not 8, because you are taking the time from the origin. No, this again brings us to the discussion of the system. Our scope is very important in kinematics. Now let me give you an example. In kinematics, you'll be solving some question like that a car is traveling at 20 meters per second, and after 3 seconds its velocity increases to 25 meters per second, and what is the acceleration, things like that. If we do not define our scope, so from this, our scope is from the point where the car was traveling at a certain speed and that it changed its speed. So that defines our scope. Otherwise, every car is going to start from its idling, its stop position, and then again it will come to a stop. So there is nothing to discuss really, right? The car is parked somewhere, it starts and comes back and to park it again. So if it is starting from 0, ending at 0, if we do not define our sub-scope, then we cannot solve any problem. So it is very important to define the scope. In this scenario, of course, the plot is starting from origin, but the scope is from A to F. Okay? So 25 minus you don't need to go all the way 25. Just start from A, okay? And just to make sure that we don't get confused. From A to F. So distance we already discussed. From A to F, the distance is 14. We did not bother wasting our time on this patch because this is beyond our scope. Okay? We started discussing this problem at this point. And same is the case with the time axis. Our scope starts at the second 2, not at 1, not at 0. Okay? Yeah. So 14 divided by 6, exactly, it is 2.33. And so that is our average velocity, average speed. Now the tricky part. What is average velocity? Before that, tell me what is the displacement. The person started from A, went all the way to F. What is the displacement? Just one answer? Such a simple question. Quick, please. And the rule here is, if you don't know the answer, tell me that you don't know. Okay? Don't just stay quiet. Okay, 2 minus 2. Okay. Excellent. Okay, very good. Minus 2. Nice. Okay. So the displacement is always the final position minus initial position. What is final position? That is F, and that is 1. Initial position is A, that is 3. So the displacement is 1 minus 3. That is minus 2. Yeah, it will happen. We just started this discussion today. So I expect all the mistakes. And that's why I want you to make all the mistakes today so that you don't make those mistakes tomorrow and later. So answer the questions that I'm asking. So this involvement is very good. So the displacement here is minus 2 meters. Clearly, the person was a bit displaced along negative x-axis. And what is the total time during all this? Time remains the same, which is again the same 6 seconds. So now, if you want to find out average velocity, then you have to divide a minus 2 by the time, that is 6, and that will be 0.23, I guess. Yeah, minus 0.3 meter per second. So that is very important to understand that the difference between speed and velocity, displacement and distance, how to get all that information from this position time plot, and what is the physical significance of the slope. These are all important concepts here. I'm not going to start this today. Let's digest one plot and the particulars of it. Let's stop here. Any question or confusion from the first session until now, let me know. You rock, Paul? Okay. Any question or confusion so far in Physics 1? I have a lot of questions in quiz, and I keep asking questions in practice question set. Okay, Stacy, you are actually telling her. Okay. Okay. Let me stop recording here. Then it will be an open session. It is up to you if you want to stay, you want to ask any question, or if you want to leave.